Hello everyone. My name is Hatim Nagarwala, and I work as an Azure developer lead for Microsoft and covering Middle East and Africa. So today, what we are going to look at is what is cloud native applications, how you can actually go ahead and start building the cloud native application. So the first pillar to this is developers. Developers are very essential in today's world we live in, and when you have to work with critical uh, applications, it's very critical to our business that developers play a very important role in powering this applications in organizations and in almost every industry. So there are some numbers over here that currently there are more than so this was as per the developer velocity report. There are more than 20 million software engineers worldwide, and most of them are outside of our tech industry in that case. So non-tech industries are also adopting a lot and building more and more critical applications using uh, the today's cloud. So when you talk about this, let me just hide this part. Yes. So at the same time, what happens is when you are seeing this request, there's a massive growth on the the expertise required for developers and bring all types of ideas and innovations into the place. Okay. So considering that this year 2023 there will be more than 500 million of new digital apps and services which will be developed and deployed, and this will be cross industry. So mainly it will be used for digital transformation, and it will be only used for businesses which require high productivity and they want to adapt to the recent technologies and new changes which are going to happen. So why this matters to us, right, and why we are talking about this in the start. So everything actually comes down to something called as developer velocity. Okay, developer velocity is directly proportionate to an organization's success, not only internally but externally as well. So when when organizations go ahead and increase their velocity for the developer, everyone gets benefited from it. So when developer velocity increases, the innovation increases, the developers are more confident and comfortable in their roles and what they're working on, and the teams also work more efficiently. So you can produce better and more intuitive software that has the capacity to to reach more customers and also draw more business in that case. So that is why developer velocity is very, very important. So what we do is we introduce the Microsoft Cloud over here. Okay. And what are the topics we are including or we are talking about is, if you take care of the whole thing, you have Visual Studio, you have GitHub, you have Power Platform, and you have Azure. Okay. And when we talk about the Microsoft Cloud, there is kind of a demand on, if there is a product launch, there is a high level of demand, right? And the experience actually is expected from people or the applications or the softwares which are using by millions and millions of customers suddenly. So sometimes the request gets higher during the first product launch. You saw in the recent chat gpt launch, within the first 5 days you reached like 5 million users, right? So in that case, the product launch, there is a high number of people who are joining or using the application or the product, right? In terms of holiday season, in terms of like event like FIFA, uh, things like this actually has an elasticity of demand where the demand increases for a period of time and then goes down. And here, to cater this dynamic usage, modern apps has to be built in that case. Okay. So why cloud native is important? So cloud native helps you to actually build uh, these applications which can scale at demand, at whatever demand you want. It also gives you an option to have a greater resiliency and develop better apps in a faster way. So this whenever you're going to build a new application, you need to make sure that these are available or these are very compatible with cloud. So these are called as cloud native applications because you're trying to deliver new levels of scale, performance, reliability to your end customers. And using this design patterns, you are achieving more innovation and delivering more to your business in that case. So what is cloud native over here, right? Cloud native applications, in a short, what do you say, in a description, if I tell you, is you're trying to build your application on containers or on serverless, or building your APIs and then connecting all your solutions through managed database. Okay, so cloud native applications are delivered using, all this actually comes through a key, which is the DevOps environment. So all the cloud native applications are delivered using highly automated DevOps approach, and this enables you to continually deploy your new updates, your new capabilities, and with Azure and GitHub, you can actually go ahead and enable all these capabilities and approaches to your own application. So we know that everyone is in a different stage. So what we need to do with cloud native journey is we have to meet everyone wherever you are, use the tools which you are using currently, and also work in any environment possible. So you work in an hybrid cloud environment, you work in an edge cloud environment where the cloud, where the actual infrastructure is with you, or if you work with multi-cloud environment where some of the resources are on one cloud, some of the resources on the other cloud and stuff like that. So what are the common scenarios where you actually go ahead and talk about cloud native scenarios, right? So you modernize your critical applications. You make sure that all your applications are SaaS based application, which is software as a service. You give real time telemetry data for the users so that you understand if there is something wrong, how do you actually fix it. You run this application which are distributed across different geos. So it's like if there is any disaster happening, your recovery happens really quickly in the other regions as well. You can run your applications anywhere, and these all applications can take the power of the AI. And this is now very common, which we are looking at in the recent market. So let's go through each and every scenario and how it looks like. So some of the customers try to go ahead and modernize their business critical applications, right? Just one of the examples is e-commerce systems. So you can use cloud native technologies, which helps you to scale the requirement and availability across the world, where you can manage your traffic uh, and make sure that if there is an increased demand in terms of handling your business, you are very scalable in terms of increasing your infrastructure, and also provide as much low latency as you can and high availability across all the users who are actually you are serving in that case. The second one is how you can evolve your SaaS based model or SaaS business model by going API first. That means everything is actually dependent on API economy. You might have seen a lot of applications where you build APIs for that, and you actually go ahead and try to expose a part of APIs to your end customer so that they could go ahead and start integrating it or start using that APIs in that case. This is a very good business model where your whole application can actually be a SaaS based API model where your internal applications or any external use also can be actually catered from there. The next one is IoT for data streaming. So, because of so many devices around, there's a high volume of data ingest, and this has to be also processed in real time so that, more storage can actually be scaled up. More adaptation can happen depending on, what kind of data can be catered in that case. So this high volume of data can be actually being used or can be scaled using microservices, and also it can adapt according to the load, where the load actually is coming on in that case. The next one is geo-distributed application. So for some countries, they want to put their data into their country itself, right? There are requirements where you don't want the data to actually go out of the country, but still give an uninterrupted service to them. So this geo-replicating data services, when you pair it with your DevOps environment, this approach can actually help us have high availability, plus make sure that your data is still available in the region and the cloud provider you actually want to put in. So what I'm discussing actually right now is not only uh, relevant to Azure, but it can actually be applied to any cloud platform, because these are the general terms to actually go ahead and build cloud native applications. And the last one is, sorry, not the last one, second last one is, so you build this cloud native applications anywhere you want. So, uh, there is something we have, which is called as the Azure Arc, where you can build your own infrastructure, and Azure can be installed on your own infrastructure. So you can have Kubernetes running on top of that. You can have an Azure cluster with, zero configuration on top of it. So in this way, you can have GitOps running, where your configuration can be stored into a Git repository, And your Azure Arc agents who are running can actually monitor your whole repo and make sure that the changes which are coming in can actually be deployed over there. Plus, this also enables you safe deployment practices, which helps your agents to to understand what is the desired state, which is by declared by your organization, and any deviation from this can actually return a rollback in that case. So using this Azure management or Azure Arc, you can actually go ahead and deploy it on your own infrastructure as well. The next one is how you can actually then add AI powered applications on it. So many customers wants to to accelerate their journey in development using the AI tools, right? So there are a lot of Azure AI services and OpenAI services which will help you to increase your customer engagement through bots, through enhanced security, biometric authentication, and also there are some of automating business logic options as well available using pre-built models, or these are the services. So if I give you an example, you can use cognitive search, you can use form recognizers, and some of the cognitive services you can actually go ahead and use this pre-built APIs, or you can actually deploy it onto your own containers to go ahead and use that in that case. So how you can actually go ahead and build this on Azure, right? So there are some of the services. So if when we talked about how the whole spectrum looks like, the main key area is DevOps. Okay, the DevOps can be actually attained using either using GitHub or Azure DevOps, and you can use both the tools. Either you can use Visual Studio or Visual Studio Code in that case. And the four components in your journey will help you to start, to build and create a new application. So you start with managed Kubernetes, then you go ahead and build serverless containers. You go ahead and scale your database with high quality visions, speech, language, and decision making AI models. And you create API management services on top of that. So your whole circle is actually completed. And this actually can be anywhere. This can be on the Azure Cloud. This can be on Azure Arc, wherever you feel like you can actually go ahead and do that. So let us deep dive into each and every component and understand what that component has to offer to us. So first one is the Azure Kubernetes service, right? The Kubernetes service delivers elastic provisioning for the capacity without the needing to manage the compute infrastructure. So it is the fastest way to manage Kubernetes cluster and to configure a seamless DevOps as well as DevSecOps workflow with your CI/CD integration in that case. So you can go ahead and build your applications on that. I have a small demo actually to go ahead and show it to you. Let me go ahead and do that. So one of the examples over here is how you can. So we are talking about the app deployment using AKS. So let us go ahead and start this on GitHub. So we have this code spaces. I think most of you have used this. Code spaces on GitHub is a amazing, fantastic tool, for your cloud-based development. That's entirely on your browser. So it's like, basically the same UI for the VS Code, but everything is running on the cloud, running on your browser. So what we are doing is we are running an AKS draft to create the configuration we want. And you can see here we are taking care of everything like installing of binaries, then detecting the language of programming, asking some instance information like port and what I want to run. We are going to use Helm over here as my deployment type. And again, when we are exposing this application to port 8080, I'll give like the name is context of air over here. And now I'm going to go, everything we need to containerize this application has been generated for me. Okay. We are going to choose GitHub Actions over here for the work action-based flow. And also prompt me to give some more information, enter that including the cluster I want to deploy on. And once I have all this information, now you can see that GitHub is trying to go ahead and generate a workflow for me, correct? I will go ahead and commit this code that has been generated. So you can see there is a thing taken care for me automatically. It's the best practices for the application deployment. And this all will be committed to GitHub. So it will be pushed onto in my repo. So let's go ahead and see at my GitHub repo and see whether the commit is there or not. And more importantly, what we are going to see over here is there's an action that has been started as well, right? So this is the action, correct? That whatever the code was generated for you by the draft tool is actually taking care of the deployment of this application as well. And let's look at the Azure as well. You'll see that there's already a Kubernetes resources created. And the Contesto AI application from the code to communities is just a few commands away. Correct. Obviously, deploying an application is great, but for real world application, it's critically important that you monitor that application. That's why we are very excited to talk about the Grafana service as well, which is available in Azure. So you can see all the monitoring services in the same resource of AKS, and it's just a few commands away. So you can go ahead and have it available for your cluster, and you can still monitor your application. So in this demo, we are putting in Grafana, and I will go back then again back to your Azure portal once this is created, and we'll see our AKS cluster where it is located. We should have the Grafana instance. So let us go there, and you can see the Azure Managed Grafana instance. And if I go into this instance, I can see all the metrics and the data provided by the container insights, which is visually fantastic. And if you're very familiar with the Grafana interface, you can see how many information, like how many requests per seconds, using pods and all different things you want to run in your application, right? In this sense, this Grafana is an open source product. It's available to you on Azure or wherever you want to run it. Okay, if you want to run it on a VM as well, it's possible to do that. It's exciting to see how we could actually run this application on top of industry standards, and also the open source software. So in a way, you can actually focus your energy on making the actual software development rather than on what tool you actually want to use. So that's why we just included one of the open source examples over here on how it would look like. The next one is the Azure Container Apps. So Azure Container Apps is a serverless container based hosting service. I'm sorry. uh, that helps you to to stay focused on your applications instead of you worrying about managing the infrastructure behind, right? So it supports mostly event driven scale. In fact, you can also do a scale down zero instance if you're not using it, so you won't pay anything. That's the benefit of the cloud. And if you're suddenly getting a lot of incoming requests, you can quickly and dynamically scale up to thousands and thousands of instances to handle that load. In that case, it encapsulates all the best practices of microservices, such as service to service communication, reliability messaging through pub/sub. So you can go ahead and spin up that. So what you can actually go ahead and build using the Azure Container Apps, right? So you can, here are some of the common examples. You can run a microservice. You can deploy public API endpoints. You can host your web applications in that case. You can have event-driven processing. You can have background processing applications as well, right? So with each of this application, you can go ahead and dynamically scale based on whether you're getting a lot of HTTP traffic, whether you have more event-driven based processing, or you need more CPU or memory load. So in that case, you can use any scalars like tool where, so for an example, you can use Keda scale triggers where you can actually go ahead and scale your scale your services in that case. The next demo we'll look at is a company called Contesto Air. Again, so who will actually work with modernizing their workloads that manages customer bookings. So let us start and look at that demo. So what we are doing over here is, let's go with the basics, and we started a new subscription. We don't have any containers running. So what we do is we checked in the repository on GitHub, and so this is a JavaScript based application. And what we want to do over here is we want to run it as a microservice on Azure. So to get this deployed and running at a cloud scale, we just wrote a single command, and yeah, it's on GitHub. We give it a name, and that's it. It started. Uh, Now it's starting the CI/CD action, which is building the code and running my test, and then it will deploy my application to the container apps. And it is set up with the DevOps workflow, which I said at any time. So whenever we make an improvement, you can simply open a pull request, and it will go ahead and update it. And there you go. You have your completed, and your site is up and running. Let me show you one more little thing where from Azure Container Apps, from a runtime and management perspective, how I can continue to configure this app without directly jumping from command line, but directly going to the Azure management portal instead of managing it that way. So uh, when you're working with the serverless scale, you get the container apps, and you can configure it to scale way down to zero instance, or as I said, when there's no traffic, you can go to zero, and I'm not paying for anything for that, right? If there is no traffic, and I can also configure the real time through rules and incoming requests. So I can put that over here, how many concurrent requests can come in, and I can queue messages, event streams, event databases, and all the other stuff as well. So up next is the Azure Functions. Many of you have already used Azure Functions. It's event-driven serverless code functions where it will help you to accelerate app development with and triggers and bindings. Like, it provides you an enhanced developer experience to execute small custom codes on demand, and without having to worry about executing on how it would scale, how would you pay for the compute, and when your actual function is running. So in terms of modern applications like the Azure, uh, uh, Red Hat OpenShift, the Spring apps using Java, the app services, and static web apps. So it has to offer you different types and services where you can modernize your entire application portfolio with any type of languages you're using, and developing using single page applications as well. The next one down the line is the Azure Cosmos DB. So in when your application is living in silos and most of the applications need data to function, Cosmos DB provides you an unparalleled SLA backed speed. So you can actually get global access, instant elasticity, and you can actually go ahead and build more open source APIs using MongoDB, Cassandra, and no ETL based analytics over operational data, right? So you can guarantee like 99.999 availability, and it also provides you like end-to-end database management with serverless and automatic scaling for your database operations. So your scaling at your application can actually be taken care of. And the next one is your Azure database for Postgres SQL. So the application innovation with a fully managed, highly available database that it gives you a maximum flexibility with a full compatibility, and you can go ahead and use your open source resources, plus an added layer would be your open source resources with protecting your data with enterprise grade security. So you can manage your compliance, your enhanced security, and also you can use Microsoft Defender for double encryption in that case. So how you can power that for unmatched data capabilities is you have a fully managed data services where you can use the SQL family, the Postgres SQL, and MySQL, Cosmos DB, and Cache, Redis Cache for Azure Cache for Redis in that case. So, and if you're going with Azure Arc in that case, you can go ahead with on-premises or multi-cloud in that case, where you can actually go ahead and use Azure with the help of Azure Arc and multi-cloud environments, which can give you capabilities like high availability, backup, security management, and also with Azure Arc, you can go ahead and manage your cloud services like anywhere you want. Like, it's in Azure, it's in multi-cloud environment, it's hybrid, it's on edge, wherever it is. Like, you can still modernize your existing on-prem applications with cloud native solutions using the familiar tools you have on Azure services in Git. Now, if we talk about the last part, which is the GitOps flow workflow in that case, for those who are not familiar with this technique, Git will act as your single source of truth for all your applications. Any changes we need on our application, you create and update and delete. It happens all on your Git repository. Okay. Lastly, all changes are observable. So whenever you get a commit history, and artifacts like pull requests and stuff, this means that all our resources will be described using Kubernetes manifest or Helm charts, and the repositories are supporting immutability, versioning, and history, and all approved changes are expected to be automatically applied, and expected to be done automatically in that case, right? So what happens finally is the reconcilers which are running on our clusters are responsible for deploying and maintaining the resources, and this the cluster state, it drifts due to the administration action, and our agents are responsible for automatically driving the cluster back to the desired state. So the git ops can actually deploy applications, keep your clusters drifting away from the state, and help the developers to bring or be on the same page. So all the production changes and uh, your track git commits and pull request can do this with uh, maybe one cluster. You have 100 clusters, or you have 1,000 clusters in that case, right? So all of them can actually be managed, like all your changes can be actually managed through GitOps in that case. So go ahead and build your applications using Azure. So we believe, like, any digital transformation journey, it helps you to be achieved, using uh, part, or focusing on your people who are working with the organization. All the tools, how you can actually go ahead and use that, and more focus is how you can actually give these tools to your people and digitally transform how we are helping every person on the planet in that case. So that's it from my side.